4, comparing methods. We're going to bring long division back for dividing polynomials in this particular. So let's say, for example, in lesson 3, you did not like this tabular method, which we're going to review here in a moment. If you don't like the tabular method, that's fine. We're going to go back and we're going to do division the way you may have done it before. Long division, it's just we're going to do it with polynomials. So ultimately you'll get a choice. Do you like tabular division better, or do you like long division better? And you'll get that choice. So that's what lesson 4 is going to be about. But before we do that, let's go through the opening exercise. It says use reverse tabular method to determine the quotient. So if we're doing that again, of course, you might want to pause the video and try it and see if you can do it on your own first. If you know that's something that you're not sure about, we can go ahead and get started with that and then roll with it. But we're going to put our divisor here on the side. So we'll put x, and then we'll put plus 5. And remember, we're going to want to put our dividend around here. And so that means we're going to have a 2x to the third, and 11x squared, a 7x, and then a 10. And so we're going to put things back in. So this goes into here as a 10. And so 10 divided by 5, that gives us our 2. And then remember, I can put this other one in here automatically, 2x to the third, and divide that. 2x to the third divided by x would be 2x squared. That only leaves me with trying to figure out that middle term. And so 2 times x is 2x. I have to get a 7x once all this is combined, so that means this has to be a 5x. 5x plus 2x would give us 7x. So that's the info that I need, 5x divided by 5. And then I get 1x. And so that becomes my particular result in that piece. And so they ask us to follow up with number 2 using your work from exercise 1. Write the polynomial, this one here, this is our dividend, in factored form. And so if we wrote that in factored form, it would simply look like this. X plus 5, and the result that we got was the 2x squared plus the x, and then plus the 2. And so that would be factored form. Factoring refers to two things that multiply to equal another value in that particular piece. Okay, so that's enough of reverse tabular method. If you need more practice with it, of course, see me. Talk to me about it. Go back and watch the video from lesson 3 and then continue working on that problem set. Otherwise, we're going to move forward and we're going to look at long division. In example number 1, the long division mechanism is already set up. And so they give us a little bit of guidance. They say assuming, right? Assuming that x is equal to 10, then we can take and do this division, 1,573 divided by 13, using polynomial division. So how does that look, right? We have to understand where these values came from. The 13 became x plus 3. Remember, we're assuming x is equal to 10. So if I did 10 plus 3, I'd get my 13. 10 to the third power would refer to 1,000. This is this 1. 10 squared times 5 would be 500. 7 times 10 would be 70, and then there's my 3. So we're taking these values and we're rewriting them as polynomials. And then they want us to go ahead and try to divide this. So when we divide this, and again, if you haven't seen this done before, it's kind of a good idea to just kind of watch it. You can always rewind the video and take notes in a minute, but you might want to just kind of observe and then see what's going to happen. So we're going to take this x right here, this first one, and we're going to pretty much always use this first value for everything that we're going to work with. And so when we do that, we're going to do x to the third divided by x, and that's going to give us x squared. We always want to keep our family members lined up. Notice I did not write it above here. I wrote it here so that the x squares would match. And so at that point, I'm going to do the distributive property and say x squared times x is x to the third power. So notice how those match. And then x squared times 3 is a positive 3x squared. I recommend, it's not required, but I think it's a good idea to put these in parentheses. That way you know that goes together. And then put a minus sign in front. So what we're going to do is we're going to actually subtract, because that would be the next step to long division. And so you see that x to the third minus x to the third is going to cancel out. And so then 5x squared minus 3x squared is going to be 2x squared. And then we're going to take the 7x and we're going to bring it down. Now at this point, the process is just going to repeat. So what we did the first time around, we're going to do it again. So we're going to start with this x and want to ask ourselves, how many times does this x divide into 2x squared? And so we're going to say, well, that would be 2x. So we write plus 2x. So then we're going to do the distributive property. 2x times x is 2x squared. Remember, we want that first term here to match because they're going to cancel out. And then 2x times 3 is 6x. So we're going to write 6x. And again, just for recommendation, I recommend you put that in parentheses, put a minus sign in front to remind you you are subtracting. And so 2x squared minus 2x squared cancels out. And then 7x minus 6x is 1x. Or you could just put an x. And again, we're going to take this 3, we're going to bring it down, so we do a plus 3, and then we're going to do the process one last time. So x divided by x, that's going to be a 1. So then we do the distributive property. 1 times x is x, and 1 times 3 is 3. So we put this in parentheses, put a minus sign, and then this would cancel and this would cancel, end up with a remainder of 0. And so that would be our answer at the top, x squared plus 2x plus 1 as our division result. So this is long division. Now again, you have to stop and think, did I like the tabular division method better? Or do I like what I see here? We're going to try several of these in this particular section. There's one more official example. There's 8 exercises. You only need to do as many as you need to understand how this is going to work. So let's go through one more example, right? Let's take a look at this and say it says use long division algorithm for polynomials to evaluate this. So if that's the case, we're going to write this down. So we're going to write down in the long division format, we're going to write down 2x minus 2. So we write down 2x minus 2. We're going to write our divisor bar, and we're going to write 2x to the third power minus 4x squared, and then plus 2 in that design. But now looking at it, there is one thing that we can do as a precursor right now. This is not required, but this did catch my attention. So, okay, what did we do? Let's not do that. Let's erase this and go back to there. There we go. Now, watch this idea. I just noticed it, and some of you might have noticed this. In this particular case, there is a greatest, now this does not always happen, but there is a greatest common factor in both of these. And so there is a 2 that divides into everything in the first row. So that means if I divide 2 into everything here, I get x to the third minus 2x squared, and then plus 1. Now, if I look at the denominator, right, let's put our division bar, and I notice there's a greatest common factor of a 2 in the terms here. So then I'm going to get x minus 1. The reason why it's neat to observe this is now these 2's can cancel. And so really I'm going to divide this problem here, which is going to be much nicer if you recognize it. So we're going to write x minus 1, and we're going to divide that into x to the third minus 2x squared, and then plus 1. So now when we divide, remember, in this long division idea, we only divide with this value here. So x divides into x to the third, x squared times. We always want to keep those family members lined up, the squares, the cubes, the non-variables, and so forth. So when we do that, we're going to take and we're going to do the distributive property. So we have x squared times x is x to the third power. Then x squared times negative 1 is negative 1x squared. And then I would recommend that you put this parentheses there. We draw a line, and then we're going to subtract. X to the third minus x to the third cancels out. Negative 2x squared minus negative 1x squared is going to be negative x squared when you do that. Now, this brings up an interesting thought, an idea. Notice we have an exponent of 3, an exponent of 2. Logically, the next exponent would be 1, but then we don't have that. This is where placeholders come into play. We actually need to make some room, and we need to put a plus 0x, and then we're going to then put our plus 1. We do need every part of the function to be present as a countdown, right? 3, 2, 1, and then no variable. So we do want all of those there. The reason being is because now we're going to bring down 0x. We need that. So now when we divide and we start over, x divides into negative x squared, negative x times. So we're going to put a minus x, and then we're going to do the distributive property. Negative x times x is negative x squared, and negative x times negative 1 is positive x, right? So again, we put these parentheses, put a minus sign in front. That's very important, particularly in a case like this one, where negative x squared minus negative x squared, that does cancel out, that goes to 0. And then 0 minus x, you're going to get negative x. You don't want to accidentally put a positive x there because you forgot that minus sign. And so then we bring down this plus 1, and then we're going to do this process one last time. So x divides into negative x, negative 1 time. And so then we do the distributive property. We get negative x, and then negative 1 times negative 1 is positive 1. Put that in parentheses with a minus sign, and notice everything cancels out and then goes to 0. So then we find out our quotient is x squared minus x minus 1. Again, you know, this is long division. You could do this exact same problem with tabular method. Just note, you know, it is important. It's very important here. Remember, we had to put this placeholder right here because it was missing. Now that's a check you can do before you write it. If you notice it, you could write it up front, or you could just address it as you need it. Okay, so I'm going to do a few of these. I don't know that I'm going to solve all of exercises 1 through 8. I do recommend that you go through some of these, if not all of these, and make sure you can do some of them. Uh, it says to check your work by using reverse tabular. You do not have to do that. So, we'll just make a little note, and I'm not going to scratch it out for every slide, but you don't have to do this check. Um, just make sure you ultimately decide which method you like better. So that way, when and if you're assessed on this, you can do it the way that you prefer in that design. Okay, so let's go through one more. And again, pause the video, try some. If you've already tried it, obviously you want to keep watching and see if you got the correct answer, and so forth. So if we're going to write this out, we're going to write the divisor in the front, x, and then plus 3. And then we're going to put the dividing bar. And then we're going to do our checks. X squared plus 6x to the first. And then plus 9. Everything's there. So we don't need to add any family members, right? 2, 1, 0. So we're going to divide. Remember, in this dividing mechanism, we want to always divide with this first value.
Good afternoon, teachers. Sorry for the interruption. I just wanted to let everyone know that Star AC Company is here. They're in the process of cleaning coils, so they will be shutting down the air in different sections of the building. So if you get warm, it will probably last about 30 minutes and right back up. Thanks, everybody.
All right, so they're working on the air conditioner. Anyway, if we were to take this x and divide it into x squared, that would go into it x times. Remember, put the x above the x family, the linear family. Then you're going to do the distributive property. X times x is x squared. X times 3 is 3x. I recommend the parentheses with the minus sign. This should go away. And then 6x minus 3x is 3x. And then I put a plus 9. And then we're going to do the process again. X divides into 3x 3 times. So 3 times x is 3x, and 3 times 3 is 9. So we put the parentheses, we minus, and obviously this would go down to 0. And that's what we're looking for. Our quotient would be x plus 3. I like this method. This is actually my favorite method, though I've gotten to the point where I do like tabular method. So, if you like that route, go that route. You just want to make sure that when it comes to divide these polynomials, you can do it in a way that is correct and accurate, and so forth. Now, don't blow off both methods, because I'll probably ask you to do something with both down the road. Now, let's try another one, right? So we look at this one, and we say, okay, I don't see any greatest common factors. So there's nothing I'm going to be able to do with that. So we're just going to start by writing 7x minus 1. We're going to put our division bar and check our countdown. 7x to the third minus 8x squared minus 13x, and then plus 2. It looks like all of it's there. So we're going to start with division, right? So we always divide with this first term. And so 7x to the third divided by 7x is going to be x squared. Remember, you move that one place over for the family member design. So 7x squared times 7x is 7x to the third. X squared times negative 1 is negative x squared. Put your parentheses, put a minus sign in front, draw your line. Right, we're looking to see that these two cancel out. And then so negative 8 minus negative 1, that's going to give us negative 7x squared. We bring this one down, so we bring down the minus 13x. And then this process, again, remember this is a repetitive process. So we start over, 7x divides into negative 7x squared, negative x times. So negative x. So negative x times negative 7x is negative 7x squared. Then negative x times negative 1 is positive x. Put those parentheses. We're going to subtract. We want these two to be the same because they'll go to 0. And negative 13 minus 1 is negative 14x. We bring down the 2. And then we do it one last time. 7x goes into negative 14x. Negative 2 times. And so whenever we multiply negative 2 times 7, that's going to give us negative 14x. And this is going to give us a positive 2. Here we want everything to match because that means it's going to go to 0. We don't want anything left over. That means we would have a remainder. None of these at this point have a remainder. We're going to address that in another lesson. So at this point, if you don't get a 0, assume that you divided something incorrectly. All right, let's look at number 3. Again, reminder, pause the video, try these on your own as I go through. I'm just going to work through some of these. Now, notice in this one, this says x to the third minus 27, and you got x minus 3. So in this particular case, when we divide, we need to write x minus 3, but we're missing some family members here. We've got x to the third present, but we're missing the squared piece. So we're going to put 0x squared. We're missing the linear family, so we're going to put a plus 0x, and then we're going to have a minus 27. That's going to build up everything that we need to divide this. Again, I like to put an arrow here just to remind me that this is what I'm dividing with. And so x goes into x to the third power, x squared times. We'll do the distributive property. X squared times x, you get x to the third power. And then x squared times negative 3 is negative 3x squared. We close the parentheses. This should cancel out. 0 minus negative 3. That's going to give us 3x squared. We bring this one down, so we have a plus 0x. And then we're going to divide again. X goes into 3x squared 3x times. So positive 3x. 3x times x is 3x squared. That's again an indicator you're doing the right thing. 3x times negative 3 is negative 9x. We close the parentheses, put a minus sign in front, we draw a line. These you want to be the same, so they go to 0, and then 0 minus negative 9 is 9x. We bring down this last piece, and then we do the last part. X goes in the 9x 9 times. So we should get a 9x here, and then a minus 27. Close the parentheses, subtract, we get 0, and that helps confirm that it is correct. I am going to do one more. I'm going to do number 4, and then I'll tell you what I'll do with the rest of them next. So one more, number 4, right, for good practice and measure. We kind of look at everything, see what's there, see if there's any concerns or anything like that. I don't see any greatest common factors. I see a 4, a 3, a 2, a 1, and a 0. I see a 2 here. I'm missing a term in the middle, and then I got a 3. So when I write this one, I want to write 2x squared plus 0x minus 3. And then we're going to write everything else. 2x to the 4th plus 14x to the 3rd plus x squared minus 21 and then minus 6. So when we divide, again, the rules doesn't change. We just had to add a placeholder. We're still going to divide with this one. And so 2x to the 4th divided by 2x squared is going to be x squared. Now again, you get to line family members out, so I have to start my answer all the way over here. That's x squared. Then we're going to do the distributive property. X squared times 2x squared is 2x to the 4th. X squared times 0x is going to be positive 0 x to the 3rd, and then x squared times negative 3 is going to be negative 3x squared, right? And so we put a minus sign, we draw a line, this will go away. 14, is that what I wrote? Yeah, 14. 14 minus 0 is 14. So we get 14 x to the 3rd, and then 1 minus negative 3. So that'll be like saying 1 plus 3, and so that'll give us plus 4x squared. And then we're going to bring minus 21 down. And so we'll do this process again, right? We start over. 2x squared goes into 14x to the 3rd. That's going to be 7x. So we put a plus 7x. We do the distributive property, so we get 14x to the 3rd, and we get a 0x squared. And then we get a negative 21. There should be an x on here. An x. And so we get a minus 21x. We close the parentheses, put a minus sign. This goes away. 4x squared minus 0x squared. We're going to get 4x squared, and negative 21x minus negative 21x is going to give us a 0x. So we're going to put a plus 0x and bring this minus 6 down to the bottom. And so then this will be the last time that we have to do this. 2x squared goes into 4x squared 2 times. So we put a plus 2. And if it all works out, watch this. We get a 4x squared, we get a 0x, and we get a negative 6. And we subtract all that, we get a 0. And so we find out our quotient is going to be x squared plus 7x plus 2. Right? If you need additional practice, try 5, 6, 7, and 8. Otherwise, you can go to the problem set. What I'm going to do is I'm going to write down the answers for 5 through 8, and if you need help with any of those, you can let me know, and I can give you help from there. But that'll keep me from solving these over and over. But the quotients, right? I'll give you the quotients for each one. The quotient for number 5 is 5x squared minus 1 is final answer. Remember, there are some placeholders missing in here. Like you see, the 3's missing here, the linear term's missing, the linear term's missing. For number 5, let's see, for number 6, your answer should be x to the 3rd plus 4x and then plus 1. the answer for number 7 is x to the 5th minus 2x, and then plus 7. And then number 8 is actually kind of a long answer, is x to the 5th minus 2x to the 4th plus 4x to the 3rd minus 8x squared plus 16x, and then minus 32. So again, now it's time for the problem set to get some additional practice in, and seek me out if you need additional advice, of course.